Welcome to my loom on computer networks. I'd like to talk about the definition of computer networks and the purpose in business terms, talk about how computers are connected together, the topologies, as well as peer-to-peer and client-server networks. By way of objectives for the Ministry of Education in Ontario, I'm going to talk about terminology such as configuration, topology, network. I'm going to talk about some variety or structures, topologies of networks, and we're going to talk a little bit about where those might be used. To get started, we need to define the idea of computer network. Computers are connected together, and that's not good enough. They must also be able to communicate or share information with each other and or share resources. Businesses use networks in their conducting businesses for the following reasons: reducing costs, sharing software, and collaboration. First off, as you know, you don't need to print every day, so a business could save money by buying one printer and saving it and sharing it with a number of users, so sharing expensive equipment. Also, rather than having each computer and each employee acting on their own, they can centralize things like login and group policies and file permissions and those sorts of things, as well as providing a central area for employees to save their files. And that way the business could back up one or two hard drives rather than having to depend on employees to back up their information or physically going to each computer in the office and backing up the information from those computers. As far as sharing software and data is concerned, sometimes business software is available in client or network versions. So rather than installing a full package of that software on each computer, perhaps the software could be installed on a central server and then accessed from there with a client access license, and that would be substantially cheaper. Also, certain things are necessary for or shared regularly with employees, like letterhead or certain forms or those sorts of things. They can be stored centrally and modified as necessary. So that would mean that the current version is always available to the employees. As far as collaboration is concerned, that means working together. And in computer networks, that would mean that the people could work together on a set of files in a folder, or perhaps on something like Microsoft Project, where they use a piece of software to manage how the project goes. The network would allow simultaneous access to certain documents. So, for instance, we use Google Slides or Google Docs together, and it allows for centralized document storage so that the business doesn't have multiple copies of certain documents, certain cover letters, certain forms kicking around. And that would help to avoid confusion for both the employees as well as potentially for customers who might get the wrong sorts of forms sent to them. In order for computers to put information on a network, they need to have a network card. That network card can be a physical unit, like picture sitting here on the screen, or it could actually be built in or integrated into the motherboard. Regardless, that network card has its own unique address or its own name, and it acts like a virtual postage system in which it can send or receive information. As far as the network itself is concerned, the network card would connect to a wire, a twisted pair like Ethernet or coaxial cable. It could be connecting to a fiber optic line, or it could even be connecting to a wireless network with the use of a radio antenna. In sending the information, the network card takes information from the CPU, which comes in parallel form. As you know, processors nowadays are generally 64-bit, so those 64 bits get processed simultaneously. Like you can visualize the teeth on a comb, but that doesn't work for putting it on a network cable. Those have to go on individually, one after another, in linear fashion. So the network card repackages information from the CPU so that it can be transmitted later linearly. It also would add a destination address to the packets, and then when it has all that done, packaged and addressed, then it sends the information onto the network medium. While doing that, the network card is also listening for packets that are addressed to it. If it reads or receives one, then it would unwrap that package. It would reassemble the linear data into parallel form and then provide it to the CPU for processing. Topology, or configuration of computers, and the sort of idea of how they're connected together. The first one we're going to take a look at is bus. A bus is kind of like the Christmas light idea, a whole bunch of lights on one string. In this case, you can see there's about 6 units there, maybe 6 to 8 or 10. And a bus configuration might be okay for a business depending on how much collaboration needs to happen. They're easy to set up. They're pretty reliable. Failure of one unit does not kill the network, but failure of the actual main cable or the T-connectors will kill the network. The biggest disadvantage there with the bus network would be collisions. And collisions happen when 2 network cards would try to send information on the media at the same time. Then you have the delay while that the network cards reset and then try to resend at some point, as well as obviously the delay caused by the collision in the first place. So the more units you would have on the bus, then the more possibility of collisions. That's why I said somewhere maybe 6, 8, 10 units on a bus configuration. In STAR, you have a centralized hub, which is not actually generally a computer. It would be a switch or a router or something like that. And then you have the other devices arranged around it. The hub acts as a repeater because some of these connections can be a long piece of wire or a long cable, depending on how big the facility is. It could be 200-300 meters, which is also one of the disadvantages because all these get individually wired. Even if there was 2 sitting side by side in the office, they would each get an individual wire to the central hub. Advantages: if one node goes down, the rest of the network is happy and will continue to function. Devices can be added or removed without disturbing the network. So it would be easy to connect on Wi-Fi and then disconnect when you're done. Disadvantage: the hub needs to be somewhat sophisticated in that it will prevent collisions, but it will allow multiple conversations. So you only need a pair of computers for a conversation, so you can have multiple going on. And if the hub goes down, then obviously the network also goes down. Next one we'll take a look at is ring topology. You notice that the computers here represented by dots again are set up sharing information or connected to 2 others. Information flows around the ring so that if this unit transmits to that unit, then it passes to this one passes it, that one passes it. So every device between the source and the destination need to process the data. So that slows it down a little bit. It's relatively easy to set up. It doesn't need the expensive hub in the middle. Disadvantage: if one workstation malfunctions, and then the network can go down, but they can add a second ring or an inner ring for redundancy. That's generally done for important information. Information is transmitted by token or according to token. So there's a token that passes to the computers or passes from computer to computer until it reaches a computer that wants to transmit, and then that computer would transmit, and it won't transmit unless it actually has a token. So that takes the possibility of collisions off the network. So that you can see that's a little bit better than buses, because you won't have the inefficiency of collided packets and then having to resend. But this network would be good for then maybe 8, 10, 12, 14 units, depending on how much traffic needs to go. But obviously then the more devices on the network, the more packets times the packets need to get handled, so you lose some speed there. The last one we'll take a look at is tree. A tree is a mix between star and bus. You can see that nodes in the tree in the stars are connected via bus, and this would be a good situation where you have a business with departments where there's a lot of collaboration within a department and not so much between departments. So perhaps you might have engineering and manufacturing and planning and sales, and these would talk within each other but not too much to each other. You have good speed and reliability within the stars. You have okay between the hubs, and you might need a more expensive or more sophisticated hubs, depending if there's or more higher capacity hubs, depending on how much traffic actually needs to happen then between the departments. The last topic for this presentation is peer-to-peer and client-server networks. Peer-to-peer networks are more likely to be ring or bus because they don't need a server then. The computers would run independently. They would have all their own applications installed on them. They would be networked so that they could share information. The computers would have a shared file located on the hard drive that would be accessible by other computers in the network. And if you wanted to share information, you'd put it in that folder. Could also be set up to share printers or other devices in the network using special switches. And client server, you have a server is something that provides services, and a client is something that requires services. There's a whole spectrum of dependency. In some cases, a client will be able to do next to nothing. It will be almost just a screen, a keyboard, and a monitor, and all the applications that are used would actually be run on the server. And the workstation would be only serving as a display. In that case, you'd be calling it a thin client. If the client hosts all of its own applications and minimally depends on the server for things like maybe print management and user authentication and centralized file storage, then you have what would be a thick client. The big advantage with that then is those files that get stored centrally are much easier to back up, but you have a little faster perhaps running of the applications depending on what you're using if they're hosted on the individual machine. Sometimes moving great big files across networks can take a long time. That's the end of this presentation. Thank you for watching, and have yourselves a good day.